Okay, in this video, we're going to talk about section 3.4, dealing with the product and quotient rules in differentiation. And in this video, in this section, by the way, we'll talk about how to find derivatives of products, find derivatives of quotients, find derivatives using the extended power rule, and then find derivatives of functions using exponentials. Then we're going to find equations of tangent lines and find derivatives of functions involving a combination of rules. Okay, so first of all, we'll talk about the product rule. And I want to mention something about, let's say if we wanted to take the derivative of two different functions. And I want to indicate that the use of the product rule is not the same as the sum and the difference rule. So let's say we had these two functions, like f of x is equal to, let's say 2x plus 9, and g of x is equal to, let's say 7x minus 11. Let's say I just had those two functions here. And you might think if we take the derivative with respect to x, the product of these two functions, f and g, you would think that's going to be equal to f prime of x times g prime of x. Well, I want to show that this is not going to be the case here, because let's do this. If I multiply f times g, that's just going to be 2x plus 9 times 7x minus 11. And in this case, if I use the FOIL method, as always, I will have this. First, the first term times the first term, that's 2x times 7x, that's going to be 14x squared. The outer would be 2x times minus 11 would be a minus 22x. And then the inside would be 9x times 7x, which would give me plus 63x. And then finally 9 times minus 11, that would be minus 99. And if I simplify that, that would be, I'm going to say f times g, that's going to be 14x squared. Let's see, 63x minus 22x will be 41x plus 41x, then minus 99. Now, when I take the derivative of this with respect to x, I'm going to have this. 14x squared, bring the 2 down, multiply by 14, you get 28. Copy the x over to the 1 less power, so it'll be x to the 1 or just x. Then plus, bring down the 41, the derivative of x is going to be 1. And the derivative of a constant is 0. So the derivative of f times g will be 28x plus 41. Now, let's try this. If I did the product of f prime of x and g prime of x, I need to know what the derivative is of f of x. So if f of x is 2x plus 9, then f prime of x will have to be 2. And if g of x is 7x minus 11, then g prime of x would be 7. So if I multiply 2 times 7, I would get 14. Is 14 the same as 28x plus 41? Obviously, it's not. Okay, so the product of two functions is not going to be the same as the product of their individual derivatives. So we have to come up with another way or a method of finding the product rule, and this will be it. Here's Theorem 3.6. If f and g are differentiable at x, then the derivative of f of x times g of x will be this. F prime of x times g of x plus f of x times g of x. Okay. Now, the way I remember the product rule when I took a course like this is this. I let the first function be f and the second function be s, first times the second. And I want to take its derivative. Here's how I remember it. I take the first term times the derivative of the second term, that's s prime, plus the second times the derivative of the first. Yes, I remember that. First times derivative of the second, plus the second times the derivative of the first. That's how I remember the product rule. And we're going to use that in some of these examples that I have here in this video. Starting with example 1. Let's say I want to use the product rule to find the derivative of each of the following, like in part A. Here I got y is equal to 4x squared minus 8x plus 8. That's multiplied by e to the power of x. And I want to use that product rule. All right, so what I'm going to do here is this. This first term, that 4x squared plus 8x plus 8 minus 8x plus 8, that's going to be the first term. That e to the x is the second. So off to the side, the first will be 4x squared minus 8x plus 8. Then the second would be e to the power of x. So here, if I want to take the derivative of f, derivative of the first for 4x squared minus 8x plus 8, its derivative will be, bring the 2 down, multiplied by 4, you'll get 8. Copy the x over to the 1 less power, minus 8 times the derivative of x is 1. And the derivative of plus 8 will be 0. So the derivative of the first will be 8x minus 8. And then the derivative of the second, well, if the second has e to the x, the derivative of the second will also be e to the x. Okay, because e to the x is the easiest derivative to take. That's because the derivative of e to the x is e to the x. Now, to find y prime, that would be this. The first times the derivative of the second plus the second times the derivative of the first. Now, the first was the 4x squared minus 8x plus 8. Times the derivative of the second was e to the x plus the second, which is e to the x, times the derivative of the first. That's the 8x minus 8. All right, so now we need to simplify all of this here. All right, so first of all, what I would do here is factor out take out a common factor that's in both of these terms. And in this case, you can see that e to the x is the common factor. So I'll factor out e to the x. So when I factor out e to the x in this term, I'll be left with the 4x squared minus 8x plus 8. And then plus, factor out this e to the x, I'll be left with 8x minus 8. Okay. I'm going to simplify what's inside the parentheses. Now, as you can see here, the minus 8x and the plus 8x, that's gone. And also the plus 8 and the minus 8, that's gone. So what's going to be left inside the parentheses is the 4x squared. So I have e to the x times 4x squared. And by the way, if I put the 4x squared in front, this will be my final answer for y prime, or the derivative of this function. Y prime would be equal to 4x squared times e to the x. Okay. Right, here's another example. Let's say we had something like this. Y is equal to 2x minus 9 times 6x squared minus 5x plus 2. And I want to find the derivative of that function using the product rule. And here I have to use the fact I have two functions. They're products of each other. So that first term would be the 2x squared minus 9. And then the second term would be that 6x squared minus 5x plus 2. And here I want to go ahead and find the derivatives of each one of those. For the first term, the derivative of the first term for 2x squared minus 9 would be 4x. And for the second term, its derivative would be 2 times the 6 will be 12x minus 5. Okay. So I found the derivative of the first and the derivative of the second. So now, using the product rule, which is y prime, that's going to be first times derivative of the second plus the second times derivative of the first. So the first term was the 2x minus 9. 2x squared minus 9. The derivative of the second was 12x minus 5. Plus the second, which is 6x squared minus 5x plus 2, times the derivative of the first term. That's 4x. So now we're going to simplify this. This first part right here, I will apply the FOIL method. So in this case here, if I do 2x squared times 12x, that would be 24x squared. 24x cubed. X squared times x is x cubed. The outer would be 2x squared times minus 5. That would be a minus 10x squared. The inner will be minus 9 times 12x. That would be minus 108x. And then minus 9 times a minus 5 would be plus 45. So this first part, I applied the FOIL method. This part right here, I'm going to use a distributive property. So when I do 4x times 6x squared, that would be a plus 24x squared. And then 4x times a minus 5x, correction. 6x squared times 4x, that's 24x cubed. And that's an exponent of 3. Now back to the 4x times a minus 5x, that's going to be a minus 20x squared. And then 4x times 2 will be plus 8x. Let's see if I can simplify this here. Well, I got 24x cubed and a plus 24x cubed. I can combine those. And that will give me 48x cubed. And then next I got minus 10x squared and a minus 20x squared. So here's another pair of like terms I can combine. Negative 10x squared minus 20x squared will be minus 30x squared. And another pair of like terms would be something like this. Negative 108x plus 8x. That would be minus 100x. And I have nothing to combine with the plus 45, so I bring that down. So here, y prime, or the derivative of that original function, would be 4x cubed minus 30x squared minus 100x plus 45. All right. Here's part C. Say we got y is equal to x minus 1 times x cubed plus x squared plus x plus 1. And here I want to find its derivative. So this first term, that will be the first term. This will be the second term. So if the first term will be x minus 1, then f prime of that, or the first derivative of that would be, well, the derivative of x is 1, the derivative of a constant is 0. And then the second is going to be x cubed plus x squared plus x plus 1. Its derivative will be, bring down the 3, copy over the x, subtract 1 from 3, you'll get 2, plus for x squared, bring down the 2, copy over the x, so the 2 minus 1 will be 1. So it'll just be 2x, plus the derivative of x is just going to be 1. And the derivative of that plus 1 will be 0. So the derivative of the second term is 3x squared plus 2x plus 1. Then I'm going to find y prime, which will be the first times the derivative of the second, plus the second times the derivative of the first. So y prime will be the first, which was the x minus 1, times the derivative of the second, that would be 3x squared plus 2x plus 1. Plus the derivative, well, the second, which is, of course, x cubed plus x squared plus x plus 1 times the derivative of the first, which is 1. And now let's do some simplifying here. That x will be multiplied by each and every term in the second polynomial. So if I do x times 3x squared, that's going to be 3x cubed. X times 2x will be plus 2x squared. X times a 1 will be plus x. And then I'll do minus 1 times each and every term here. Minus 1 times 3x squared will be a minus 3x squared. Minus 1 times 2x will be minus 2x. Minus 1 times the plus 1 will be minus 1. And then plus 1 times everything here will be everything you see here. The x cubed plus x squared plus x plus 1. And now we got some terms that we need to try to combine. Nothing to combine with the 3x cubed, so I'll bring that down. Let's see, 2x squared minus 3x squared. 2x squared minus 3x squared and a plus x squared. 2x squared minus 3x squared will be negative x squared. Negative x squared plus that x squared will give me 0. So these three terms are gone because they all add to 0. Well, the plus x in that minus 2x will be a minus 1x. Minus 1x plus that x also gives you 0. Okay, all that's gone. And something else will be gone. The minus 1 and the plus 1, that's gone. I got 3x cubed plus this x cubed right here. So 3x cubed plus x cubed would be 4x cubed. So the derivative of that function, y, would be 4x cubed. Okay. Now, the only calculus that I did was when I used the product rule for derivatives. Everything else after that was just simple algebra. Okay. All right, take a look at part D. We got g of w is equal to e to the w times 5w squared plus 3w plus 1. Okay. So that e to the w, that would be the first term. This 5w squared plus 3w plus 1 would be the second term. So if the first term is e to the w, then its derivative, well, that's simple, will be e to the w. Second term is that 5w squared plus 3w plus 1. In this case, its derivative will be 2 times the 5, that'll be 10w plus 3. That would be the derivative of the second term. So now y prime, of course, that's going to be the first times the derivative of the second plus the second times the derivative of the first. Okay. So now y prime, the first was e to the w times the derivative of the second, that would be 10w plus 3 plus the second, which is 5w squared plus 3w plus 1 times the derivative of the first, e to the w. Now, what I would do here to simplify this, you'll get e to the w in both of these terms. So that's the common factor that I can go ahead and factor out. So I'll factor out the e to the w. And then if I factor e to the w in this first term, I'll be left with 10w plus 3 plus, factor out this e to the w, I'll be left with 5w squared plus 3w plus 1. Okay. Now let's combine some like terms here in the bracket here. I'm going to pull the 5w squared. I'm writing this in descending powers, by the way. Let's see, for the w's, 10w plus 3w will be 13w. And then 3 plus 1 would be plus 4. So this is the derivative of g to the w, e to the w plus e to the w times 5w squared plus 13w plus 4. All right, part E. Let's say we're given the function y is equal to t squared plus 7t times 3t minus 4. And I want to use the product rule to find the derivative of the given function and simplify the result. Number 2, you're going to find the derivative by expanding the product first. Verify that your answer agrees with number 1. So let's start with number 1, using the product rule. So here we're going to use the product rule to take the derivative of y with respect to t. So the first term is going to be that t squared plus 7t. And the second term would be the 3t plus 4, 3t minus 4. That's what s will be. So if the first is t squared plus 7t, the derivative of that first term would be 2t, and then plus 7. And then for s, the second term, that's 3t minus 4, the derivative of that would just simply be 3. Now we're going to find y prime, which is going to be the first times the derivative of the second plus the second times the derivative of the first. Okay, so y prime will be the first, which is t squared plus 7t times the derivative of the second, which is 3, plus the second, which is 3t plus 3t minus 4, times the derivative of the first, which was 2t plus 7. So for here, I would use the distributive property. So I do 3 times t squared, which is 3t squared, plus 3 times 7t will be 14t. For this, I have to use the FOIL method. 3t times 2t would be plus 6t squared. The outer would be 3t times 7 would be plus 21t. The inner will be minus 4 times 2t, which would be a minus 8t. And then minus 4 times the plus 7 will be minus 28. Okay. Combine some like terms here. 3t and 6t. 3t squared plus 6t squared. That would be 9t squared. Then I got 14t, 21t minus 8t. 14t plus 21t would be 35t. 35t minus 8t. Is that right? I see my mistake. When I did 3t times 7t, this should be 21t. Okay. 3t times the 7t, that's 21t. So 21t plus another 21t will be 42t. 42t minus 8t would be a plus 34t. And then all I got is the minus 28, bring that down. So y prime would be equal to 9t squared plus 34t minus 28. That's using the product rule. The second is expanding this. So y is equal to t squared plus 7t times 3t minus 4. If I was to expand this, multiply this out, and then take the derivative of that function, here's what I have. T squared times 3t. That would be 3t cubed. The outer would be t squared minus 4 would be minus 4t squared. The inside would be 7t times 3t, which would be a plus 21t squared. And then 17 times the minus 4 would be minus 28t. Combine like terms. This would be 3t cubed, 3t cubed. Minus 4t plus 21, minus 4t squared plus 21t squared would be a plus 17t squared minus 28t. Let's go ahead and take the derivative of that. So this 3 will be multiplied by the 3 in front. That will be 9. Bring over the t and subtract 1 from that 3, you'll get 2, 9t squared. This 2 times the 17 would be plus 34. Subtract 1 from the 2, you get t to the 1 or just t. So it'll be plus 34t, then minus 28 times. The derivative of t will be 1 times 28 will be 28. So here I get y prime equal to 9t squared plus 34t minus 28. Notice that they're both the same. Using the product rule and expanded. Okay. All right, so that's the product rule for taking derivatives. Now we're going to go into the quotient rule for derivatives. And let's say that f and g are differentiable at x and g of x is not equal to 0. Then the derivative of f divided by g at x exist, and here's your derivative. The derivative with respect to x of f of x divided by g of x will be this. G of x multiplied by f prime of x minus f of x times g prime of x, all that's divided by g of x squared. Now, the easy way to remember this is using this technique. This will be the high and this will be the low. So if you do low times the derivative of the high minus high times the derivative of the low, all that's divided by the square of the low. Or you can say low d high minus high d low, divide that by the square of the low. Okay. So let's look at this example here. Here we're going to use the quotient rule to find the derivative of each of the following. So we got f of x equal to 9x minus 6 divided by x minus 6. Okay. So here's how we can write this. The high would be the numerator, 9x minus 6. The low is your denominator, x minus 6. In this case, if the high is 9x minus 6, then the derivative of the high would be just 9. And the low is x minus 6, so d low, the derivative of the low, that's simply going to be 1. So now we can use that to find f prime of x, which is, of course, the low times the derivative of the high, that's going to be x minus 6 times 9, minus the high times the derivative of the low, that's 9x minus 6 times 1. All of this will be divided by the square of the low. And the square of the low is at x minus 6, so it'll be x minus 6 quantity squared. And from here, we go ahead and simplify. So f prime of x will be equal to, distribute the 9 over the x minus 6, you're going to get 9x minus 54. That at 1 times 9x minus 6 will be 9x minus 6, but since you got the negative sign, that minus sign distributes and change the sign of every term inside the parentheses to the opposite. So the minus makes a 9x minus 9x. The minus makes the minus 6 a plus 6. All that's divided by x minus 6 quantity square. When we simplify this, the 9x's add to 0. Negative 54 plus 6 would be a negative 48. All that's divided by x minus 6 quantity square. So here the derivative of f of x being equal to 9x minus 6 divided by x minus 6 will end up being negative 48 divided by x minus 6 quantity square. Okay. All right, next is part B. So we had this. F of x is equal to 5x squared minus 9x plus 6 divided by 3x squared. And I want to find the derivative of that using the quotient rule. All right, in this case here, the denominator is the high. That's the 5x squared minus 9x plus 6. The low is my denominator, 3x plus 2. So let's find d high. The derivative of the high, which would be 2 times the 5, that's 10. Bring over the x to the 1 minus 9. So d high would be 10x minus 9. Now for the derivative of the low. For 3x squared, its derivative is just going to be 3. So now, f prime of x is this. Low times the derivative of the high. The low is 3x plus 2, and the high is 10x minus 9. Well, the derivative of the high would be 10x minus 9, I should say. And then minus the high, which is 5x squared minus 9x plus 6 times the derivative of the low. And notice I'm putting the 3 in front of the 5x squared plus minus 9x plus 6. All that's going to be divided by the square of the low, 3x plus 2, quantity squared. Okay, so now let's simplify this. I'm going to bring down the f prime of x. I'm going to use the FOIL method on that 3x squared times 10x minus 9. So here, 3x times 10x would be 30x squared. 3x times minus 9 would be minus 27x. 2 times 10x would be plus 20x. 2 times minus 9 would be minus 18. Using a FOIL method here, this one I'm going to distribute the negative 3 over the 5x squared minus 9x plus 6. So minus 3 times 5x will be a minus 15x squared. Minus 3 times the 9x will be a plus 27x. Minus 3 times the plus 6 will be minus 18. Oh, that's divided by 3x plus 2 quantity squared. All right, let's see if we can simplify this a bit. I know minus 27 and a plus 27, that's gone. I also know minus 18 and, well, that's not going to give me a 0 there. So I guess all we can do is 0 out the 27 x's. Let's see here. 30x squared and a minus 15x squared will give me 15x squared. Plus 20x is all I have, so it'll be plus 20x. Minus 18 and a minus 18, that would be minus 36. All divided by 3x plus 2 quantity squared. So that's what f prime of x is going to be. 15x squared plus 20x minus 36 divided by 3x plus 2 quantity squared. And I don't think you're going to be able to factor anything out in the numerator, so that way you can divide out common factors. Okay. All right, here's another example. F of x equals to 8 e to the x divided by e to the x plus 7. So let's go ahead and identify the high and the low. In this case, the high would be my numerator, 8 e to the x. The low would be the denominator, e to the x plus 7. So now let's find d high, the derivative of the high. That's going to be easy. So here I can bring down the 8. The derivative of e to the x is e to the x. So the derivative of the high will be e to the 8e to the x. The derivative of the low, that's also easy. For e to the x, its derivative is e to the x. The derivative of the constant plus 7 will be 0. So I have the high and the low. also D high and the D low. Let's find f prime of x. So it'll be the low times the derivative of the high. The low is your e to the x plus 7 times the derivative of the high would be 8e to the x minus the high times the derivative of the low. The high would be 8e to the x times the derivative of the low, that's e to the x, all divided by the square of the low. And the low is e to the x plus 7, and we square that. All right, let's go ahead and factor out an e to the x. Better yet, let's factor out 8e to the x. That's in both of these. So f prime of x is, if I factor out the e to the x, well, actually 8e to the x. 8e to the x is factored out of this term. I'm left with e to the x plus 7. And then minus, if I factor out this 8e to the x here, I'll be left with e to the x divided by e to the x plus 7 quantity squared. And notice inside the parentheses in this numerator, the e to the x's are gone. I'll be left with 8e to the x times 7 divided by e to the x plus 7. And that quantity is going to be squared. So 8e to the x times 7 would be 56e to the x divided by the quantity e to the x plus 7 squared. So that's what f prime of x will be. 56e to the x divided by e to the x plus 7 quantity squared. Now take a look at part D. Let's say we got y is equal to 3x minus 1 times 4x plus 5. That quantity is raised to the negative 1 power. Now I'm going to rewrite this using the fact that a to the negative m power will always be 1 to the a, 1 over a to the positive m power. So with negative exponents, we can write that as 1 over the base raised to the positive exponent. I'm going to use that with this right here, that 4t minus 5 to the negative 1 power. So I'm going to have y is equal to, the 3t minus 1 will be in the numerator, but the 4t minus 5 will be in the denominator. And it's going to be to the first power, but we can write that as 4t minus 5. So I get y is equal to 3t minus 1 divided by 4t minus 5. Now I can use the quotient rule on this. So I'm going to identify the high, which is 3t minus 1. The low is 4t minus 5. The derivative of the high is just simply going to be 3. And the derivative of the low is simply going to be 4. Now we use the quotient rule. So y prime would be low times the derivative of the high. That's 4t minus 5 times the derivative of the low, which is 3, minus the high times the derivative of the low. The high was your 3t minus 1. The derivative of your low was 4. Now I'm putting the 4 in front of the 3t minus 1. All that's divided by the square of the low. 4t minus 5 quantity squared. Now let's simplify that numerator a bit. If I distribute the 3 over the 4t minus 5, 3 times 4t will be 12t, minus 3 times 5 will be 15, and then distribute the minus 4 over the 3t minus 1, Well, minus 4 times 3t will be a minus 12t. Minus 4 times a minus 1 will be plus 4. All divided by the quantity 4t minus 5, and that's going to be squared. Simplify the numerator, 12t minus 12t. That gives me 0, so that's gone. Negative 15 plus 4 will be negative 11. Oh, that's going to be over 4t minus 5 quantity squared. And that will be your derivative of the function for y. Negative 11 divided by 4t minus 5 quantity squared. All right, then we got part E. F of x is equal to e to the negative x divided by the square root of x. Okay, I'm going to write e to the negative x as a positive exponent. So that means f of x is equal to, the numerator will be the square root of x, the denominator will be e to the positive x. So I'm writing e to the negative x using positive exponents. Here I can use the quotient rule for that. So the high is my numerator, the square root of x. The low is the denominator, e to the x. Well, if the high is the square root of x, then the derivative of the high, if you recall from previous videos, of taking the square root of x as its derivative, 1 over 2 square root of x. And if the low is e to the x, then the derivative of the low, well, that's obvious. That's going to be e to the x as well. Now let's find f prime of x using the quotient rule. So f prime of x will be this, the low times the derivative of the high. So the low is e to the x times the derivative of the high would be 1 over 2 square root of x, and then minus the high times the derivative of the low. That'd be the square root of x times e to the x. All that's divided by the square of the low, e to the x quantity squared. Now we're going to simplify all of this here for f prime of x. I can factor out e to the x in the numerator. That's the common factor. So factor that out. Factor out the e to the x here, you'll be left with 1 over 2 square root of x minus, factor out e to the x here, you'll be left with the square root of x. And all this is going to be divided by, now e to the x and you square it, if I write it out as a factor twice, it would be this, e to the x times e to the x. And one of those e to the x's will divide out. So here you're going to be left with, let's see, f prime of x. That will be equal to 1 over 2 square root of x minus the square root of x in the numerator. Your denominator will be e to the x. All right, so let's say I want to write that using negative exponents. I can do that. So I have 1 over 2 square root of x minus the square root of x. And that would be multiplied by e to the negative x. If I take this out of the denominator, that exponent for the x, that exponent for the e becomes negative. And distribute e to the negative x over what's in the parentheses. This is what I have as a final answer. 1 over 2 square root of x times e to the negative x, and then minus the square root of x times e to the negative x. And that would be the final answer for the derivative of that function. 1 over 2 square root of x times e to the negative x minus square root of x times e to the negative x. Okay. So that's how we apply the quotient rule to take derivatives. All right, next we'll look at the extended power rule. Okay, now we did talk about the power rule back in section 3.3. For that video, you can watch that as well to get a idea of what that power rule is. And we only define that for positive integers. But what about for negative integers? If n is any integer, positive or negative, then here the derivative with respect to x of x to the n, that's going to be the same thing. We just bring the exponent down in front of the x, copy the x over, and it will be to the 1 less power. So the n times x to the n minus 1. Okay. So that will hold true for positive integers. It also will hold true for negative integers as well, like in example 3. Let's say I want to find the derivative of y equal 40x minus 40x to the negative 7. Y equal 40x to the negative 7. Now here I'm using dy dx as my derivative notation. Really doesn't matter. All right, so let me bring over the 40, and using that extended power rule, I'm going to bring down the negative 7 in front of the x. So you do that, copy the x over. This will be to the negative 7 minus 1, because that's to the 1 less power. Simplify this, this will be 40 times negative 7. That's negative 280. Bring over the x. If you do negative 7 minus 1, you're going to get negative 8. So I have negative 280 times x to the negative 8. But let's write that using positive exponents. The negative 280 stays in the numerator, but that x to the negative 8, if I pull it inside, pull it towards the denominator, that 8 becomes positive. So it'll be negative 280 divided by x to the 8. Okay, so that's part A. Now in part B, we got y equals to 100 divided by x to the 7th. Well, let's write this using negative exponents here. So I have y equal to, write the 100, pull the x to the 7th out of the denominator, that exponent of 7 becomes negative. So I have y equals 100 x to the negative 7. Now I can use that extended power rule to take the derivative of this function. So here dy dx, or y prime, doesn't matter. Bring down the 100. Let's take the derivative of x to the negative 7. Here we pull the negative 7 in front of the x, copy over the x. That would be to the negative 7 minus 1. Now, if I simplify that, 100 times negative 7 will be negative 700. Bring over the x to the negative 7 minus 1, which will be negative 8. So I have negative 700 x to the negative 8. Now, if I write that using positive exponents, this is what I'll have. Negative 700 in the numerator. If I pull the x in the denominator, that negative 8 becomes positive 8. So the derivative of y would be negative 700 divided by x minus 8. All right, part C looks like this. Here I got y is equal to y is equal to 3x cubed minus 13x minus 5 over x to the 5th. All right, let's write this by pulling that x to the 5th out of the denominator. So I still have the 3x cubed minus 13x minus 5. But if I pull the x out of the denominator, that 5 for that exponent of x will becomes negative. So My y is now 3x cubed minus 13x minus 5x to the negative fifth. Now dy dx, let's find the derivative of that. Well, take the exponent of 3 multiplied by the 3 in front, it'll be 9. Copy the x over to the 1 less power, that'll be squared, so it'll be 9x squared. Minus 13x, let's take the derivative of that, it'll be minus 13. Now for minus 5x to the fifth, if I take the negative 5, well, minus 5x to the negative fifth, if I take the negative 5 multiplied by the minus 5, it will be a plus 25. Copy the x over to the 1 less power, negative 6. Because you have to think of negative 5 minus 1. That will give you negative 6. Okay, so let's write this using positive exponents. I have 9x squared minus 13 plus the 25 will be in the numerator. If I pull that x to the negative 6 in the denominator, then I'll have a positive exponent of x to the 6. So my derivative will be 9x squared minus 13 plus 25 x to the 6. Okay. All right, next we'll look at the derivative of e to the kx. Now, if you recall, in the last video that I did on the rules for differentiation, I did talk about e to the x. And the derivative of e to the x is just simply e to the x. But let's say you had a constant in front of the variable x in the exponent for e. Here, when we take the derivative of that, the derivative with respect to x of e to the kx, that's going to be this. The constant that's in front of the x, you write that down, and then we take the derivative of e to the kx, which is e to the kx. Since the derivative of e to the x is simply e to the x. So now let's look at example 4, part A. Here I want to find the derivative of the following. In this case here, let's say I want to find the derivative of y is equal to e to the 7x. So applying this theorem up here, this will be y prime is equal to the coefficient of my x in that exponent, which is 7. I'll write that down. And then the derivative of e to the 7x is just simply going to be e to the 7x. That's all there is to it. Okay. So pretty much I started off part A with an easy one, showing you this theorem, how that theorem is applied to take that derivative of an exponential function. Part B. Say we got f of x is equal to 4x times e to the 6x. F of x equal to 4x times e to the 6x. This time, we got 4x multiplied by e to the 6x. That means we need to use the product rule. So here I'm going to identify the first term. In this case, that's going to be 4x. The second term would be the e to the 6x. Well, the first term is 4x, so that means that the derivative of the first will have to be simply 4. And then for the second term, which is e to the 6x, its derivative will be using that definition, using the derivative of e to the kx. Here, that constant would be in front of the e to the 6x. Because the derivative of e to the x is e to the x. So there we have it. Now, f prime of x, that's simply going to be first times the derivative of the second plus the second times the derivative of the first. And in this case here, simplify this. The first term was 4x. times the derivative of the second, which was 6 times e to the 6x, plus the second, which was e to the 6x, times the derivative of the first, which is 4. Now, if we simplify all of this, 4x times the 6, that's going to be the 24x. Then bring over the e to the 6x plus, well, I can pull the 4 in front of the e to the 6x, and I'm done with that problem because I can't combine anything. And I mean, I could factor e to the 6x out if I wanted to, but it pretty much wouldn't matter. So I can leave that as 24x e to the 6x plus 4e to the 6x. That's my final answer. All right, now take a look at part C. Now we got f of x equal to 7x over 8 e to the 9x. And here I want to find its derivative. I got a numerator and a denominator. That tells me I need to use the quotient rule for derivatives. So the high, which is the numerator, is 7x. The low, that's your denominator, 8e to the 9x. So if the high is 7x, the derivative of the high will have to be 7. And if the low is 8e to the 9x, the derivative of the low, let's be careful here. Bring down the 8. Let's take the derivative of e to the 9x using the derivative of e to the kx. That's going to be that coefficient of x, which is 9. And then it'll be e to the 9x. Then if I multiply 8 times 9, that'll be 72. So I have 72 e to the 9x. Now we're going to find f prime of x. That would be the low times the derivative of the high. That's 8e to the 9x divided by, times the derivative of the high, that's 7, minus the high, which is 7x, times the derivative of the low, 72 e to the 9x. All that's divided by the square of the low, 8e to the 9x, and that's going to be squared. Now let's see if I can factor out that e to the 9x, because that's in both of these terms. So if I factor out the e to the 9x, or better yet, that 8 and that 72 has a common factor of 8. Let's factor out the 8 along with that e to the 9x. Might as well do that as well. So if I factor out 8e to the 9x, from here, I'm left with 7 minus, now let's take a look here. That 72e to the 9x divided by 8, I'm going to be left with, well, e to the 9x will be gone. 72 divided by 8 will be 9. So it'll be 9 times that 7x. Oh, that's over. Well, 8e to the 9x is used as a factor twice, so I'll just write 8e to the 9x twice. And then I'm going to divide out the 8e to the 9x. So this divides out with one of those 8e to the 9x's. I'll be left with 1 in the denominator. And I'm going to simplify that 7 minus 9 times 7x. I bring over the 7 minus 9 times 7x will be a minus 63x all over 8e to the 9x. And that will be as far as I can go with that problem. So the derivative of that function would be 7 minus 63x divided by 8e to the 9x. Let's look at this example 5. Here we're going to find the equation of a line to the tangent to the given curve at x is equal to a. Here we're going to use the graphing utility to graph the curve and the tangent line on the same set of axes. Say we got y equals 6x over x plus 5 and a is equal to 3. Okay. Well, let's see here. If a is equal to a is equal to negative 3. Well, if a is equal to negative 3, then let's see, that y is going to be the same as f of x, but in this case, I'm letting that be f of a. And I'm going to find f of negative 3 by substituting each of those numbers with a, or those variables with a. So it'll be 6 times negative 3 divided by negative 3 plus 5. Well, 6 times negative 3 is negative 18. Negative 3 plus 5 would be 2. Negative 18 divided by 2 will be negative 9. So my ordered pair would be negative 3, negative 9. But I do need the slope of the tangent line. That's where I use the quotient rule for this problem right here. So here, the high is the numerator, 6x. The low is the denominator, x plus 5. Well, the high is 6x. The derivative of the high is just 6. And if the low is x plus 5, your derivative of your low would be 1. So here, we're going to use that quotient rule, which is this: low times the derivative of the high. So it'll be x plus 5 times 6 minus the high times the derivative of the low. The high is 6x times the derivative of the low is 1, all divided by the square of that low, x plus 5 quantity square. Let's simplify the numerator first. 6 times x will be 6x, plus 6 times 5 will be 30, minus 6x times 1 will be 6x, all divided by x plus 5 quantity square. And in this case here, your 6x is add to 0. 6x minus 6x, that's 0. So dy dx will be plus, well, just a 30. Divided by x plus 5 quantity square. That's your derivative. I'm going to use that to find out what the equation of that tangent line is, or the slope of the tangent line. Let's start with that. The slope of the tangent line is this. Take the 30 over, my x in this case is negative 3. So it'd be negative 3 plus 5 quantity square. Now, negative 3 plus 5 will be 2, and 2 squared would be 4. So I'll have 30 divided by 4, and if I wrote that in simplest form, it will be 15 over 2. Just divide the numerator and the denominator by 2. So the slope of that tangent line would be 15 over 2. Okay. So now I have the slope of the tangent line, and I have this point, negative 3, negative 9, where x1 will be negative 3 and y1 will be negative 9. This is where I'm going to use the point slope form, which is in this case, y minus y1 is equal to the slope times the quantity x minus x1. So here y minus y1 would be negative 9, equaling to the slope that's 15 halves. times the quantity x minus x1, which is -3. So if I rewrite this, y minus a -9 would be y plus 9. And then that's equal to 15/2 x plus 3, because x minus a -3 would be x plus 3. Now distribute the 15 over 2 over the x plus 3, you're going to have this. Let's bring down the y plus 9. I'm distributing 15/2 times x, that'll be 15/2 x plus, that 3 is like 3 over 1 times the 15/2 would be 45 over 2. Now I need to get y by itself. I'm adding 9, so I need to subtract 9 on both sides. So this will be y is equal to, I'm going to bring down that 15/2 x, and I'm going to use my calculator to do 45/2 minus 9. So in this case here, figure this out. Okay. All right, let's see here. 45/2, that'd be 45 divided by 2 minus 9. Then press your math key, select number 1 for fraction, select enter, and that will end up being a plus 27 over 2. Okay. So the equation of the line tangent to the curve y equal 6x over x plus 5 at x equal -3 would be this. Y is equal to 15/2 x plus 27 over 2. Okay. Now, if we were to use a graphing utility to graph the curve and the tangent line, here's what we will do. I'll go to y equal to, let me clear these equations out. And in this case here, y equal 6x over x plus 5, I'll do this 6 and then get the x, divide that by, and then left parentheses for x plus 5, x plus 5, close parentheses. And then go down to y2 and enter this equation right here. That's the equation of the tangent line. 15/2 x, I'm going to put the 15/2 in parentheses and then get the x plus, in left parentheses, 27 divided by 2. Let's see if I can press graph here and see what happens. There's the equation of the original function, the graph of y, and this red line is the graph of the tangent line, y equal 15/2 x plus 27/2. Okay. Okay, the last thing in this video I need to cover is combining derivative rules here. Combining derivative rules. There are some situations that call for the use of multiple differentiation rules here. Like in this example right here, example 6. Here we're going to use the quotient rule to find the derivative of the following. Now, here we got y is equal to 2x plus 8 times 3x plus 6, all divided by 4x minus 3. Now, if we were to use the quotient rule on this, here's how we will start that. Y prime is going to be equal to the low, which is your 4x minus 3, 4x minus 3, times the derivative of the high, that's the derivative of that numerator. Here, the derivative of that numerator, I'm going to have to use the derivative with respect to x of this right here, 2x squared plus 8 times 3x plus 6, and then minus the high, which is that 2x squared plus 8 times 3x plus 6. And that's multiplied by the derivative of the low, which is 4x minus 3. And all that's going to be divided by the square of the low. So here I'm using the quotient rule for this. The low times the derivative of the high minus the high times the derivative of the low. All that's going to be divided by the square of the low. Now let's simplify this. Bring down the 4x minus 3. Notice here, if we take the derivative of this, we have to use the product rule. We have to use the product rule because I got the product of two functions here. So that means the product rule, when I use the derivative, take the derivative of that product rule, is going to be this. The first term, which would be 2x squared plus 8 times the derivative of 3x squared plus 6. The derivative of 3x plus 6 would just be 3. And then plus the second, 3x plus 6, times the derivative of the first. 2x squared plus 8, its derivative will be 4x. And then minus, let's bring down the 2x squared plus 8 times 3x plus 6, and then take the derivative of 4x minus 3. That's going to end up being 4. And again, this whole thing is going to be divided by 4x minus 3 quantity squared. Now, y prime will be this. All right, let's simplify what's in the bracket, and let's FOIL this out. Let's start with what's inside the bracket. Bring down that 4x minus 3. And then distribute the 3 over the 2x plus 8. This will be 6x squared plus 24. Plus, distribute the 4x over the 3x plus 6. This will be 12x squared plus 24x. Minus, I'm going to pull the 4 in front and use the FOIL method on this, on the 2x squared plus 8 times 3x plus 6. 2x squared times 3x will be 6x cubed times 2x, well, plus 2x times 6 will be a plus 12x squared. Enter 8 times 3x will be plus 24x. And then the last 8 times 6 will be plus 48. And that's still going to be over the 4x minus 3 quantity squared. All right, here comes the next line. Simplify what's inside this bracket here. Bring down that 4x minus 3. Let's see, 6x squared plus 12x squared would be 18x squared. And then I'm going to bring down the plus 24x plus 24. Now, if I distribute the minus 4 over everything inside the parentheses, this is what I'll have. Minus 4 times 6x cubed is minus 24x cubed. Minus 4 times 12x squared would be minus 48. Let's see, minus 48x squared. And then minus 4 times the plus 24x would be minus 96x. And then minus 4 times the plus 48 would be minus 192. All over 4x minus 3 quantity squared. continuing on, that 4x minus 3, well, I have to do 4x times each and every term, and then minus 3 times each and every term. 4x times 12, 4x times 18x squared will be 72x cubed. 4x times a plus 24x would be a plus 96x squared. 4x times the plus 24 would be plus 96x. Then minus 3 times 18x squared would be minus 54x squared. Minus 3 times the plus 24x would be minus 72x. Then minus 3 times the plus 24 would be minus 72. Now we will bring down the remaining terms. And every bit of this will be divided by still 4x minus 3 quantity squared. Okay, now we're ready to combine some like terms here. And by looking at this, I got a plus 96x and a minus 96x. That's going to be gone. That adds to 0. But I'm going to have to combine everything else. 72x cubed minus 24x cubed will be 48x cubed. 96x squared and minus 54x squared. And I'm missing something else. This should not be a 48x squared. That should be x cubed. That should be 48x squared. (96x cubed minus 54x squared would be 42x squared. 42x squared minus 48x squared would be a minus 6x squared. And then I got minus 72x, which is all I have. And then minus 72 and a minus 192 would be minus 264. Every bit of that will be divided by 4x minus 3 quantity squared. And I will go no further than that. So the derivative here will be 48x cubed minus 6x squared minus 72x minus 264, all divided by 4x minus 3 quantity squared. So this problem is an example of where you have to use a combination of differentiation rules, mainly the product and the quotient rules. Okay, so that will conclude this video on section 3.4, dealing with the product and quotient rules. Feel free to contact me if you have any questions about any of the homework that's in my math lab for this section, or if you have any questions about the material that was presented in this video.